Yes, folks, welcome to a new chapter, chapter number 5, and we are going to talk about lightning and all about lightning phenomenon, including a very rare phenomenon which you might not have heard about, that is ball lightning. And I have chosen this in continuation with the breakdown in air, what we discussed in depth in the last lectures, because lightning is a breakdown or the loss of insulating properties of atmospheric air in very, very long gap distances as compared to what we discussed in the last lectures. We considered the maximum depth gap distance between the electrodes in the laboratory of the order of 7 meters. But here we are going to talk about what happens when the gap distance is in kilometers. So what we are going to learn is the breakdown phenomenon in extremely long air gap, the deleterious effects of lightning. Before that, I'll also be talking about where does the lightning prefers to strike. It has its own preferences, and amazingly, certain preferences are there. Then it does damage, causes a lot of damage to the living being, to the structures, to the nature, etc. We'll be talking about that. And then how to protect ourselves and our property from lightning, from the devastating effects of lightning. We'll be talking about, and then we will go to the phenomenon of ball lightning, as I mentioned, and uh, we'll be talking about a very uh, well-known incidents which took place in northern India, and it was an episode known as Munochwa, which was actually ball lightning. I have investigated that in depth, and I'll apprise you about it. So the uh, yeah, what is lightning? As I mentioned, what you see in the lightning is nothing but a very, very strong leader breakdown. Breakdown taking place with very strong leader channel. You must have seen lightning in your life, and it is so interesting, it is so enchanting sometimes, but at times it is dangerous. So the lightning is a very interesting phenomenon which has a lot of damaging effects, and that is why it has been considered to be a, uh, a weapon of the god to punish the bad. That is done in all over the world. Uh, the Greek mythology, the Indian mythology, everywhere we'll come to it. Huh? Our earth, if you consider it to be, is uh, like a capacitor. How? Capacitor comprises of two electrodes. You can see one, the high voltage electrode. Let's say the one, you would draw it here, one high voltage electrode, and another one, a ground electrode. And this is your ground electrode, let's say. Okay, and the ground electrode, you can take it for granted. there is not a better ground in electrical sense also than the Mother Earth. So this is the Mother Earth, you can say, the ground electrode. And what forms the high voltage electrode is the cloud. The clouds have charged particles. That means they have clouds contain a lot of static charge, and accumulation of static charge gives rise to potential. So this is the high voltage electrode of the capacitor I'm talking, and this is the ground electrode. In between is the dielectric. What dielectric is it? Nothing else except the atmospheric air. When the potential of the cloud increases rapidly, or it may increase slowly also, but the gain in potential is higher when it increases rapidly under storm conditions because of the friction, etc. The clouds acquire very large quantity of charge, and the potential in is in hundreds and hundreds of thousands of megavolt. Excuse me. And then the air, when it is not able to sustain the potential, a breakdown through the uh, air takes place. So our earth is like a huge natural capacitor. The electric charge acquired by the clouds form the high voltage electrode, as I explained, and the earth is the ground electrode. The atmospheric air in between provides the dielectric, the insulation, and that is how it's a natural capacitor. Under thundery conditions, the clouds acquire excessive of charge within short period of time. Then the high potential gradient of the electric field intensity gives rise to wide scale partial breakdown phenomenon beneath the clouds. That is what happens. Uh, let's see the, yeah, this is a very typical uh, lightning photograph, actual lightning photograph taken at the Grand Canyons in the United States appears to be, where the clouds, the process of breakdown is beginning at the clouds when the clouds have acquired very high potential. As you can see, when the clouds acquire a very high potential, just beneath the clouds, the well lighted areas, as you can see it here, this area, there is in a very large area, is a bright light there. Where is the bright light coming there? Is nothing but widespread streamer corona takes place there because of the potential at the clouds. You know what is streamer corona. And when the streamer corona is spread over a large area and the potential is further gained by the clouds, we have also learned a constriction phenomenon, that is the all the streamer channels join together to form a stem, that is the beginning of the leader, which is at the center here, as you can see, takes place. And then the leader propagates further with its branches in the gap further down and down and down till it is able to reach at the suitable location on the ground. And it is not just one single channel, there are branches of the leader channels, and mind it, at the tips of all the branches of the lead leader channel. The central leader channel is strong enough, but the branches are not that strong. That how does it make it strong or less strong? It is the intensity of current flowing in this discharge channel. So at the tip of the leader channels, there will always be streamer corona, which generates the required number of charged particles to flow in the leader channels. The leader channel is formed uh, only after a certain magnitude of current is able to flow through it. That is, the number of charged particle is acquired in it. So that is created by the streamer, and that those charged particles, because below there is a strong dielectric, the insulation is still healthy, the charge always tries to acquire the least resistance path. It flows in the direction of the development of leader upward. We'll see to that. Yeah. So this is how uh, the streamer partial breakdown phenomenon beneath the clouds develops into the leader channels. And during lightning strike, the clouds evacuate when the conductive path between the clouds and the ground is established. You can imagine the clouds would evacuate with its static charge instantly over the least resistance path formed by the leader channel. And the impact of lightning uh, is least if this charge or the current in the channel finds its passage to the ground. And to go inside the ground, it needs certain specific, you can say, certain minimum magnitude of earth resistivity where it is able to go and penetrate through and go inside the ground, not remains on the surface of the ground. If it remains on the surface of the ground, or if it is not able to find passage to the ground, it has so many side effects, so many effects, and which we'll be talking one by one. And one of the effects is when it remains on the surface, the charge interacts with the soil and gives rise to ball lightning also. That is what we are going to talk about. The lightning activity is much higher near the equator. It is not the same all over. You may say it's a fine day around you, and there are maybe number of fine days around you. There is no lightning activity, but a satellite photograph is available continuously, tracking the lightning activity over the ground or over the earth, in the total earth. And it is said that every second at least about 50 lightning uh, phenomenon or lightning discharge take place. Of course, all the 50 per second do not strike the ground. It is estimated that only 90% of the lightning discharges remain within the clouds. That means cloud to cloud lightning discharge takes place, and that is of the total, as I said, 50 lightning discharges. If you consider the whole earth, every second is taking place. And out of that, about 10% or less would be striking on the ground. When it takes place between the two clouds, how do you feel it? It is nothing but thunder. The thunder sound is there. Why there is thunder sound? It is interesting too. Or when it strikes on the ground, again there is a sound. You remember, you learnt that uh, the leader produces which type of sound? The cracking sound. So the cracking sound between cloud to cloud, when it takes place, the leader channel, in the core of the leader, what you have seen just now, the temperature is of the order of thousands of Kelvin. Temperature in the leader channel, which is a very bright channel carrying very large magnitudes of current. It could be, in worst cases, more than 200 kiloamperes of current, but lasting only milliseconds. And you can imagine when such a large channel, such a large current is flowing through the channel, it would expand the air. And whenever expansion of air is there, what happens? You hear a loud sound. You firecrackers and everything, they expand the air and you hear the sound. You can hear the thunder sound when lightning between the two clouds takes place. Sometimes you might have felt it shatters the window of your house. And imagine, we'll be discussing in detail, when this kind of uh, thunder sound is developed because of lightning within your house, what will it lead to? Can you guess? It will lead to nothing but an explosion without explosive. We'll be talking in detail about that when we talk about the damaging effect of lightning. What we learned, and I tried to explain it to you. It has been studied systematically also. The mechanism of development of lightning. You know that there are ways to estimate the electric field intensity. So in this configuration, the top electrode is a plate, very big electrode or plain electrode, or it's like a it's a plain electrode given proper shape. So it is simulating the cloud here, the big one on the top, and you apply the voltage on the large plain electrode, and on the ground you have a electrode projection, a smaller dimension electrode projection is there on the ground. This is the smaller dimension electrode projection on the ground. So the field intensity between these two electrodes has been estimated by finite element method. And as you see, there is a high field intensity at the electrode where the potential is being applied. But this high field intensity also gives rise to a second high point of this field intensity here at the tip of the electrode. So you can imagine, when the electrode potential is rising in with some proportion, the electric field intensity at the electrode on the ground will also rise. If it is a very sharp electrode, you can imagine the field intensity rise will be very high, extremely non-uniform field. And depending upon the size, shape of the electrode on the ground, you can say a high field intensity would be induced at the ground also. When this happens, something must also some phenomenon must also take place at the ground electrode where you are, which is grounded. The field intensity, as I have always tried to explain, is in the dielectric. Dielectric is the air at the tip of the electrode, always. So the field intensity in air at the tip of the ground electrode also develops and acquires a certain magnitude. When it is very high towards the last stage of the breakdown, this could also develop some kind of partial breakdown phenomenon. Now, you can imagine what kind of partial breakdown phenomenon would develop here. Let's finish this first. On the ground, it revealed the FEM studies the existence of a very high intensity of field just below uh, uh, no, there is a very high field intensity just below the high voltage electrode, that is here. The field intensity is highest, and you can imagine here when very high field intensity is there, avalanches produced, ionization will be there, avalanches produced will be above critical amplification, and which type of stable corona develop here? Streamer corona. Here, streamer corona, streamer develops here. And the same as we have learned, the streamer, wide scale streamer, still the potential is rising, constriction, formation of stem, leader channel going downward, and simultaneously on the ground electrode, a similar phenomenon would develop. So you can say the field intensity at the lower electrode on the ground will have the mm, lower magnitude of field intensity, but it will be there. It will develop there. Yeah, we have learned this figure, and we have tried to explain what happens with the field development of fields between the clouds and the ground. Yeah, the phenomenon is once again in the uh, over the passage of time, over increasing voltage, which takes up time. That is, when the potential acquired by the clouds rises above the level required for the inception of partial breakdown, the streamer corona. First, a widespread streamer corona begins to take place in the air just below the clouds or the cloud limits and the region of highest field intensity. So this is what actually takes place here. You can say when the that is the first step. And figure 2 shows, as you can see it here, where the clouds are uh, simulated by a big plane electrode. The streamer channels are given rise to in the photograph also you can see as in the previous photograph also the streamer corona takes place here in the clouds. Okay, the streamer channels are given rise by above critical amplification process in which the electric field assisted ionization as well as photoionization is taking place. And you can imagine the mm, the streamer corona. Uh, yeah, yeah, interestingly, very interesting. When streamer corona is taking place here, You know, every corona activity develops or generates charged particles. That means all partial breakdown activity generates charged particles. Now the charged particles developed by this streamer corona, what we are talking about, in which direction will they travel? They will always travel in the direction of least, uh, in the direction of least resistance path. And where is the least resistance path for the charged particle generated by a streamer breakdown mechanism? Upward, because below there the dielectric, that is air, is very strong, is offering very high resistance. But the streamer channels are conductive. They would offer lower resistance path. So the charged particles developed by the streamer would travel upward. When they travel upward, where are they linked to? They are linked to the clouds. In fact, it is self-regenerating process of charged particles or static charge on the clouds. Because of its own field intensity, the static charge in on the clouds, because of the streamer corona below there, would increase, and when the charge particle or the charge acquired by the clouds increases, it develops in the form of potential. Where the more of charge, higher is the potential. That means the potential below the clouds would increase by the streamer process. This is something very interesting to just understand. I hope you are able to get it. And that means that there is a rapid increase in the charged particles self-generated by the clouds, and increase in potential, which assists in propagating the phenomenon of breakdown further, which turns into stem breakdown phenomenon, turned into stem bunch and leader corona. That all takes place in this lightning phenomenon very fast, actually. In milliseconds, it takes place. Simultaneously, as we have learned, the field, a high intensity second peak of the field is second peak of field is uh, developed there, as we learned by the FEM calculation. That may be of lower intensity electric field in the dielectric in air at the tip of the ground electrode. That will also, when the induced field intensity at the ground electrode increases, that will also develop into some phenomenon, and it can be very easily again a streamer corona stream, because it is lasting over the time, and the charged particle generated by the streamer corona taking place at the ground electrode tip, in which direction will they travel? They can't travel upward because the healthy air is there, and which is offering very high resistance, insulation resistance. Obviously, the charged particle generated at the ground electrode tip would travel towards the least resistance path offered by the ground. So they will travel downward. As you see, this is traveling downward. The charged particle generated there on at the clouds, because of the potential at the clouds, to travel towards the clouds, increasing the potential of the clouds itself. So, but the uh, leader corona propagates towards the ground. It is given potential at the top, charged particles are moving upward, but the leader is propagating downwards. As you can see, the leader is propagating downwards, and in this case, the streamer, or in some cases also, weak leader breakdown process, partial breakdown process, propagating upwards. When the downward propagating leader having at the tip the streamer corona, and the upward traveling streamer corona uh, to propagating upwards towards the cloud. When they come very close to each other, the total breakdown of insulating properties of the air takes place, and ultimately, in which direction will the charge travel? Again, in the direction of least resistance path, that is downward towards the ground. So that is the ultimate, that is how the lightning uh, strikes on the earth. Yeah, perhaps uh, uh, we can see some, yeah, we can see some interesting video. You see, this is the downward uh, channel propagating downward from the clouds, as I explained, propagating towards the ground. Mind it, this has been photographed with 103,000 frame per second camera, and this bright light was the complete breakdown. Leader channels propagating downwards, having at the tips the streamer and the bright light there. Yeah, the same thing has been photographed. What we I tried to explain. This has been photographed with a special camera, very special camera, which is a high-speed camera, which can take 103,000 frames per second. And this has been played for you here in slow motion. How and all this takes place in maximum milliseconds. We'll see in the next uh, video how the uh, how the breakdown upwards takes place. Okay, yeah, this we this is in this video you will see an upward moving lightning. That means from the ground electrode, how does it moves upward, and the downward moving and upward moving breakdown channels join together to for the lightning to strike. Hmm? Yeah. See, this is the upward moving channel from an object, and how the charge on the cloud has increased and for the total breakdown has taken place. On the right also you see upward moving uh, breakdown channel. This is also done by the same camera, and this is uh, by very dedicated people. They have photographed and right, and this gives us a good explanation what we have learned in the last few minutes. This is the you see upward, downward, and the lightning strike photographs. Upward moving cluster, as we call it, to be triggering corona. Yeah, as I said, the charge of the clouds increases in the process, and which helps in lightning to strike or lightning to occur. It is upward moving. Number of upward moving have been put together, and this is intercloud, the cloud to cloud formation over a considerable time under the storm conditions. The lightning takes place there. I hope you have understood well now the phenomenon. Yeah, I hope you've understood well the phenomenon of lightning. How does it uh, come over the ground, or how does it take place? Yeah, now you can imagine one thing. Every where does the lightning prefers? Let's talk about where does the lightning prefers to strike. Before coming to the damaging effects of lightning strikes, we must also learn where does the lightning prefers to strike. As you've seen, when you have an electrode, maybe at the ground potential, but at the tip of the electrodes in the dielectric, that is in the air, some field would be induced because of the high field density at the clouds, and some phenomenon develops there. And that helps in lightning to strike on that electrode on the ground. So you can imagine any electrode on the ground is vulnerable. Lightning may prefer to strike on those electrodes on the grounds, and which is the most widely spread electrode system on the earth today is nothing but our power system. Power system, power transmission lines over transmission lines spread thousands and thousands of kilometers all over the world. Then there are other tall buildings having a lot of electrode, lot of metal on the top of the building. There also the lightning strikes. The power system is very prone to lightning strikes. And if you want the to protect your house, you can put a put an electrode, that is lightning conductor, that is nothing but lightning conductor, connected to ground. So let the lightning get attracted towards that, and as soon as the lightning strikes there, the current would follow the least resistance path towards the ground. And let me tell you, nothing will happen to you or to your house when this lightning current is uh, let go through the uh, go to the uh, earth. Earth has got a great property, as I was mentioning right in the beginning. It absorbs any amount of charge, that is current. In any electrical circuit, the magnitude of current does not die, it does not reduce. The same current flows in the circuit. What reduces is the potential in the circuit reduces because potential drop, IR drop takes place. So the potential applied would reduce towards the ground, but not the current. Current would go towards the ground, and when it is able to go penetrate through the high resistivity surface of the soil on the top, when it is able to penetrate through, it will go to ground and will not make any difference to you, will not make any damage to you, and you will hardly feel any effect of it. And that is why you must have realized by now, we have earthing electrode or the grounding electrode system. We put big metallic plate connected with the conductor on the surface of the ground, and the metallic plate is put something like 3 to 4 meters inside the ground, and any amount of electric charge or current in the circuit is connected to this electrode system of the electrode and the earthing plate, and the uh, current goes to the ground without making any effects. So the ground uh, ground electrode system, grounding plates are very important, and if any circuit current or even the lightning current is let uh, go through the light through the conductor over the plate, uh, no harm is done. Why do we put 3-4 meters below the ground? The topsoil is rendered to be more dry if it is not continuously raining, because the water always has a tendency to go below lower level, and the topsoil will have higher resistivity because of less humidity, less water content. But when you go few meters below the surface of the earth, surface of the ground, some amount of humidity or the moisture is always present in the soil, which reduces the resistivity of the soil. Lower resistivity means higher conductivity. So the current is conducted towards inside the ground. When it is able to go inside the ground, you don't feel it at all. So I think we can make a stopover for today in this lecture, and we will um, learn about the damaging effects of lightning strikes, and a number of episodes I have investigated. I'll explain it to you, and how do we protect ourselves from lightning strikes. So thank you very much. We'll meet in the next lecture with further. We'll be talking about the lightning effects. Thank you very much.